it is my deep honour to be able to introduce Professor Kondo. He is a scholar of some quite renowned in Japan, one of our great landscape archaeologists. I like to see him as the Japanese Vince in some ways. He is quite a renowned scholar for landscape archaeology, for Paleolithic. He also does a lot of work in Oman, and I know he has won the Foreign Ambassador's Prize for his work in Oman, and I think we're all very proud to have him here and tell us about his work. He's also here to start setting up relationships between Secondai, which is one of his hats he wears, but also the Research Institute for Humanities and Nature, which is the pan-Japanese institute for researching in our area, with the University of Bradford, and hopefully in the next few years we will see more development. Robin's visit to Japan was one of the first stages for that, and hopefully that will continue on in the years to come. So I look forward to that, and hopefully you will return and give us many more speaks in the future. And may I introduce Professor Kondo, everyone?
All right, can you hear me? Okay. So thank you very much to introduce me, Simon. It is my great honor to give my presentation today as a first guest lecture on the 50th year of Department of Archaeology, Bradford. So congratulations to the Bradford success of this history of the archaeology research. So today I'm going to talk about my recent research on the ecological niche modeling of Paleolithic populations in Eastern Hemisphere. I hope, I'm afraid this topic is slightly off the focus of this department's research. However, I hope you enjoy this adjacent area as a future directions of research. So this is not so much related to our new joint collaborations with Bradford, but still have some sense of what the Japanese and East Asian archaeology contain this presentation. So I shall go to the this talk. So my talk is really loose today. So just 36 slides. So that's I come I try to speak easily as far as possible, and please ask me questions. Also, I'm very happy to receive your comments and in the presentation. A quick introduction of myself. So my first name is called Yasuhisa, but it's difficult to pronounce for British people, maybe. So just I'm going by Professor Kondo, but please friendly call me Kondo-san. San is just a prefix, the suffix to express some respect in Japanese language. So I am a professor in Research Institute of Humanity and Nature located in Kyoto, Japan. That is shortly called RIN. And at the institute, I am served now as a chair of that is a director of the PhD program of Global Environmental Studies, the Graduate University for Advanced Studies, Sokenda. So that is a dual system. I'm working mainly based at Research Institute, and that Research Institute joins the Graduate University called Sokenda, Japan. I will introduce a bit more about RIN and Sokendai in next slides. And also I served as associate member of Science Council Japan, and also visiting scholar of National Institute of Science and Technology Policy, NISTEP, Japan. So my research field is roughly speaking, three fields. The first, the archaeological geography. or mainly as Simon introduced me, mainly working in Oman in Southeast Arabia. So the fieldwork was continuing for more than 18 years. And also, very recently, I started fieldwork in Japan with Simon and his team. And also today, this topic is a kind of digital archaeology. So I got PhD in 2010 in University of Tokyo as a kind of GIS research on the Jomon settlement patterns. So that is the beginning of my career as archaeological geographer. And so today I come back to this topic to present. And also nowadays I'm interested in transdisciplinary methodologies that my institute Lean pursuing. So that is a joint research collaboration with other domains of research and also associated stakeholders like government and also companies and also NPOs and local residents to tackle the local issues like social ecological issues like, for example, water pollution and, for example, global warming adaptations and for example, disease and others. So, and also in my work is related to cultural heritage management, and that is also the topic of transdisciplinary research. So the cultural management, the heritage management is really connected to the cultural sustainable development and also community-based development of the local culture activities. So I'm really now interested in this direction of research also. So let me explain a bit more about my institute, Research Institute Humanity and Nature. So that is called RIN and also in Japanese Chikyuken. So that institute was established in Kyoto in 2001 as a National Inter-University Research Institute. So this Inter-University Research Institute, very unique system in Japan in comparison to other countries, leading countries like UK. So this institute is conducting a joint research with the academic community of specific domains that cannot be realized or cannot be achieved by single universities or a single lab. So, so this institute is related on the topics in sustainability research and other university research institutes, for example, including astronomy, biology, genetics, and physics, for example. And also, this Dean is also a member of National Institutes of the Humanities. From this channel, we open to the AHRC fellowship. So Dean, so you can apply AHRC overseas fellow to study at Lean as one of the choice in the NIFU institutes. So, and also the Lean is characterized by conducting interdisciplinary research and sometimes transdisciplinary research projects address social environmental problems mainly in Asia and Africa through the lens of humanity and nature interactions. That is a unique point of and strong point of this institute. And it means this is one of the oldest socio-ecological synthesis centers in the world. And recently, the institute opened a PhD program in global environmental studies, Sokendai. So, and this address, if you are interested in, please visit our webpage. And also, it is important for you what the Sokendai is. So Sokendai is founded in 1988, so that is much younger than Bradford, and as the first national graduate university in Japan, and that is conducting the high-level world leading research with this the Inter-University Institute. So we have now 20 programs all based by individual research institute. And then the RIN is one of these located in Kyoto. And other things related to archaeology, for example, the National Museum of Japanese History and Folklore hosted one Sokendai course program, and also National Museum of Ethnology host another. And then International Research Center for Japanese Studies, Nichibunken, and also our institute. So there are 4 choices for archaeology student and also researchers to collaborate with Japanese counterpart in inter-university institutes. And it is important to note here that Sokendai and the University of Bradford entered into an MOU this year. So it means not only RIN, but also other institute you can visit with the scheme of this MOU. So this is just a list of what our students are pursuing in the Global Environmental Studies program. Unfortunately, there's no archaeology topics, but interesting enough, so they are tackling mainly Japan and other Asian socio-environmental issues through for example, theater activities, digital museum, air dome planetarium, and educational models. Such kind of the methods are now applying for sustainability study. So that is kind of transdisciplinary approach. So that is really a new trend. So that's why I want to show this list. So let's move to my today's main topic of the early modern human migration to Eurasia. So ecological niche modeling is conducted to understand this topic. So this map is taken from. I'm missing the bottom strings, but it's by et al. Appeared in the Science in 2017. So this map shows a possible journey route of early modern humans or Homo sapiens from East Africa through to Europe and also through to South Asia and Southeast Asia through to Oceania, Sahel and Sundaland, and then also going to Central Asia, North Asia, East Asia, through to up to Japan, and then Homo sapiens also, of course, they reach out through Beringia to Northern and South American continents, but this research is focusing on the expansion of modern human up to Eurasia. So now genetic studies and also archaeological studies validated there are 2 pulses or 2 waves of the Homo sapiens dispersal. The first wave is early dispersals happened in 120,000 years through to 60,000 years. That is a white arrow represents the route in first dispersals. And that route is characterized by this southern route towards South Asia to Oceania. And the second wave is called later dispersal now, and that is for first arrival of modern humans in Europe. So that was started, roughly speaking, after 60,000 years ago, and the first modern humans reached in Levant in 55 Ka. Ka means 1,000 years ago, and could be in towards European plain reached 43 or something. So this date is corresponding mostly similar to the Homo sapiens appearance in Central Asia, and also, interestingly enough, the Sunda and Saffronlands in Southeast Asia and Oceania, Australia. And a bit later came to East Asia, including Japan. So my question is how and why they made such a deep behavior to reach out or extend their niche towards diverse environmental conditions. So when I was postdoc, I joined a large-scale research project called Replacement of Neanderthals by Modern Humans that was started 2010 and ended in 2014. And that project was succeeded by the Cultural History of PaleoAsia project, started in 2016 and continued to recently. And in this, the PaleoAsia project, more than 50 experts joined and worked together in 5 research groups, namely Paleolithic archaeology and also behavioral archaeology, and then also cultural anthropology. And interesting enough, that is social science oriented approach with the natural science approach, employing mathematical biology and also paleoenvironmental sciences. So I was in charge of the database management as a postdoc and then collaborators. So we compiled the an online database called PaleoAsia DB. So that database stores information on the upper and middle Paleolithic sites in Eastern Hemisphere. Eastern Hemisphere means, the longitude 0 towards 90 east. So roughly speaking, that is covers from Britain Island and also African continent, Eurasia, and Oceania. Yeah, so that's a region. So let me briefly introduce this database. Now it's available online. So you can access through that QR code if you like. Just click and see. And this database comprises 5 main components. The two is of these most important information is the site itself and the cultural layers in of the sites, and also that is associated with radiometric dates, I mean radiocarbon dates, OSL dates, and other methods of datings, and also risk industries, so that are risk techno-complex of the risk stone tools, and also references. So this PaleoAsia DB aims to collect fundamental information for geographical and chronological framework to understand the settling process of Homo sapiens or modern humans in Asia. That is the original aim. But not only Asia, but also Africa and also Oceania, and Europe is included in our scope. And so that means we cover geographically Africa, Europe, and Asia and Oceania, and we call this as a general term Eastern Hemisphere. So we cover the chronological period from 20,000 years ago, or 20 Ka, to Holocene transition. Roughly speaking, 12,000 years or something. And we compiled only excavated site because when we count survey site the number of the site increasing, and but also data reliability is some kind is a question. So we used Claris FileMaker, that is a very simple card style appropriate database software provided by Claris, that is a affiliated company of Apple, and the cloud version to co-edit the entries from remote institute and offices. So now, after 12 years of compilation, we disclose the database at the following URL since 2023. So just that is a bit technical, technique-oriented slides. So that shows data structure and cardinality, or the relationship of the tables. It's very simple. So the one site is contains that is a site contains a yellow at the table. Site table contains, for example, ID and the name of site and latitude and longitude and the site type, etc. And one site contains one or more layers, cultural layers, the excavated layers. So we usually excavated the Paleolithic sites at the horizontal layers. But that is a case for the cave and shelter sites in Europe and East Asia. However, in the Lucian Plain, that is not the case. That the open site is common. So that I didn't know that, and that makes huge discussions with archaeologists in regional archaeologists. So layer record also has identifiers, and that is unique identifiers, and then layer name and periodization. For example, in this case, that is a relative chronology. MIS, marine isotope stage, is used for the relative chronology, and also, for example, fossil remains. That is simply presence or absence. Homo sapiens or Neanderthals, or for example, others like bone tools presence or portable art presence. So that kind of simple information was stored, and also. And one layer may contain 0, 1 or more radiocarbon or radiometric dating records. So that records is compiled using and connected using layer ID to layer card. And these informations are also connected to reference, but the reference and site and also layers are many to many cardinality, because one reference may contain more than 2 or more sites informations, and one site can be reported by the multiple references. So many to many cardinality is not good for the conventional relational database. So we use index to control the matching. And the reference is that is a very generic reference informations. For example, author, year, titles, series, volume, pages, and that is also put the URI, that is a DOI, digital object identifier, or ISBN to link to online repository. So that is now that is very how can I say, business as usual. But some 15 years ago, that is still demanded to develop. So this is a layer record, the example of the layer records as a list. That is a Denisovan site, for example, and one choose one record that is one record of site first, and site card, and for this is a Lucian expression of Denisovan cave, and then English translation, and then we have latitude and longitude, and the cytotype is cave, and then there are a lot of layers contained, so that the information is listed here, and also reference is attached in the right column. And then when clicking this button of detail, so this is the detail of the layer information, one layer. For example, this case, stratum 11, that is belonging to early Upper Paleolithic, but that is the terminology is really dependent on the archaeologists, researchers' definition and thoughts. So that is very sometimes not consistent. So we try to identify or determine the period very large chunk, like UP Upper Paleolithic or Middle Paleolithic MP. So that's so using this kind of large scale, very coarse in resolution, but large scale periodization, we try to grasp the large scale trend of cultural behavior of the paleo people, paleo humans. And also this cultural information, we attach the dating informations and also references and also lithic technologies, for example, calcul transition. This is the local terminology, but we can compare this kind of local terminology to understand the lithic techno-complex, the diversification, and also a kind of unification. And also this is dating card. Yeah, that is very simple scientific standard or the standardized information was contained. And again, this is a site card, and then we move to the reference card. So that is also the simple the generic format, the word standardized format. And also one reference card is connected to a site and also lithic industries, like that. So this kind of relational database works to sort our archaeological classification or typology or archaeological ontology to very machine readable manner. So after 12 years of data collection and editing, we compiled more than 3,300 sites with 7,600 layers, and also the similar number of dating samples with that was extracted from 2,800 references. So my research question is I ask ChatGPT to draw this illustration, and sometimes that is no good. So I asked to retouch some, but still the figure next to the leftmost people, this figure has a modern backpack, so no good. Just this is a trial practice. But I want to express through this illustration to my research question: how did humans construct their ecological niche in environmental change? So the first modern humans departed from East Africa through Levant to Europe in the Ice Age. So sometimes that is a very tough journey to go through different cultural, environmental conditions even in 1 or 2 generations. So, what is the ecological niche? So that is the terms in ecology. And yeah, today I'm talking about a niche construction that is defined as an endogenous causal process in evolution in terms of ecology. So it works by ecological inheritance, comprising inheritance of natural selection procedures previously modified by niche construction, or generic inheritance in evolution. So I'm not very expert of this niche construction theories, but that is the kind of in terms of human behavior, that is a kind of cultural behavior. That is niche construction is against natural selections, for example. So through time, this diagram shows through time, ecological inheritance occurs through the semantic information and the physical resources, and that is kind of adaptation, and that makes in the biological inheritance or genetic inheritance through generations. So the niche development is really highly connected to the adaptation and the environmental factors. So that is in the sense of archaeology that was criticized by the as a environmental determinism. However, some cultural behavior may enlarge or expand the niches. So that is not the simple environmental determinism. So that is highly debatable. And it is important that the human ecological inheritance includes a social transmission and inheritance of cultural knowledge and material culture. So that in the sense of archaeology, this part is most important. But this ecological or environmental adaptation is related to millennium scale abrupt change of paleoclimate. So this climate change is now we are facing global warming, for example. That is, yeah, most of the scientists admit that is artificial humans, anthropogenic the phenomena. However, this past, for 200,000 years, the humans are very, how can I say, not so much influential to the climate, except for past 150 years or something. So without human influence, anthropogenic effect, the climate, paleoclimate is a kind of changes in cycles or patterns. That is for example, roughly speaking, 1,000 years cycles are called Dansgaard-Osuga cycles, found by these Dansgaard and Osuga, and the other pulses or cycles are complicatedly joined to form these complicated patterns. And yeah, that was partly, for example, explained by isolation. I mean the sun energy change, and sometimes that is some part elements can be explained by the atmospheric and ocean dynamics. So, but anyways, we have this patterned cycles of climate change. So, using these patterns, we can explain the human ecological niche. So, that patterns repeatedly appears. So we can take, for example, summer and winter, or in some given time period, the coldest time periods and warmest periods, for example, to roughly estimate the human response to climate change. And for ecological niche modeling, that is a computer-based modeling to simulate ecological niches of a species. That is developed in ecology first. So that is first applied to, for example, migration birds and also plants. But in 2006 or just just 2 decades ago, I mean, William Banks and teams from University of Bordeaux, France, applied ecological niche modeling to Paleolithic populations first. And I just copy, imitate his approach to do this, to estimate population niche in response to environmental settings. So location of sites per population group as input that is extracted from PaleoAsia database. And that simulation, we divide the data set. We kick out 10% of the experiment data, and the rest of the 90% I use for experimental data. And we prepared paleo-environmental variables, including, for example, that is a large set of paleo-environmental variables are now available in a format of open data. And of these, we took surface air temperature of summer and winter, and also rainfall, snow depths, and the vegetation water potential means the humidity and what is connected to the vegetation, and also wind speed. For that, these variables are coming from palaeoclimatic data, and also elevation was taken from DEM, the global bathymetry models, because the sea level also fluctuated. And then, for example, LGM, last glacial maximum of the 22,000 years, the sea level is as low as negative 130 meters or something alike. That depends on the region to region, but in average, that's this depth is at the lowest sea level the humans experience so far. So using this data, we run the machine learning model called Maxent. That is a free software based on the maximum entropy model. And this is the parameters, and then this model calculates the contribution of each environmental variables, and then also calculate probability occurrence for each pixel. So in this model, 1 pixels is I think that's 10 kilometer by 10 kilometer or something. And I try 10 replicators because I kick out 10%, and then we try 10 replicate runs for cross variation. That is 10-fold method. So, and for this specific experiment, I took the last integration experiment, RIG 127K models for used for a proxy. So this model is shows this is an example of the Greenland ice sheet fluxes from 127 to 190 Ka, modeled by the international team called Community Earth System Model, SESM2, with a Community Ice Sheet Model, SESM2, of the coupled model intercomparison project that is called CMIP, now phase 6. So that project, the paleoclimatologists of the worldwide gathering together to compare their models. So, and create a better one. Now that approach is now useful, for example, IPCC report for climate change. That is the same. So now this fluctuation is a pattern. However, we can extract that from this window, time window, most cold phase and also warmest phase. So we took the time window around 126 Ka for a cold phase proxy and 120 Ka for one phase proxy. Just this is proxy, and this is based on the idea or assumption that paleoclimate is fluctuated in a pattern and repeating. So some years ago, 2 decades ago, the ecological niche models require the interdisciplinary collaborations. Now, with the paleoclimate data released as open data, and also archaeological data is also open, so we can do this for myself. So it is a kind of a solo interdisciplinary work. So now archaeological data and also paleoclimate data and paleovegetation and also paleoterrain data are getting together to ecological niche model. So this is a result of the Middle Paleolithic sites. From that is compiled in the PaleoAsia DB, and that was unique number was 942 sites. This is very large time period from roughly speaking 200,000 years ago up to say this case, for example, 60,000 years or something. In this case, archaeological record refer to, for example, Lubaroa technique for the marker of Middle Paleolithic, which is very simple definition. And for Upper Paleolithic, that is the number of sites are increased. Sorry, the now unique number is 2,251 sites recorded, and that you see the then scatter of the site in Europe and also Eastern Asia. So this is a result of the Maxent based ecological niche model. So this is the MP, Middle Paleolithic cold phase proxy. So in this map, heat map, red and orange represents a higher probability of niche construction, while pale blue to dark blue stands for the low niche probability. And this table in the middle shows the response contribution of the environmental parameters. And the PC means a percentage of contribution. That means relative weight of each environmental variable calculated through machine learning. So that variables are sorted by PC. And the next column, PI, that was permutation importance. That is a relative stability of sites, stability of the PC of each variables from different random sampling tests. That means robustness of the variable. And AUC at the bottom, that is the area under the curve, and that is the machine learning indicator to represent model's prediction ability. So if this is sorry, that is missing. I'm sorry, very sorry. This is 0.847 now, and that is excellent performance. So at a first glance, the Europe to the south of the 50 degrees north line is highly niche regions, with and also this is the case for North China Plain and yellow highland, yellow soil highland, and then South Korea. And the most of the variables, among the variables, the TSH, surface air temperature of DJF means December, January, February seasons are impacted high, and also JJA means the June, July, August coming next second, and also snow depth, rain contributed much. And this dots stands for the location of sites presence, but this model is extrapolatedly predict the presence probability without the actual presence of the sites. For example, in the Sahel belt, a bit higher, and also Central Asia, that is the rim of Taklamakan Desert, and also south of Himalaya predicted high. And also, it is noted the north and south slope of Caucasian mountains. So in comparison to this, this is a one phase, a bit back, 4 and 1. You see the difference. Just some very slight, but some part, the niche is expanded. For example, south of Himalaya, for example. And then next, this is a UP code and UP1. So what is the difference? Yeah. For Upper Paleolithic, there are a lot of sites recorded in Japan and also South Korea and also Western Europe. So that is predicted very high. But very interestingly, here, the southern rim of Himalaya, from Punjab through to Assam, is predicted very high without actual archaeological site located and reported. And now, this UP phase, snow depth is really contributed to these predictions, and also JJA, June, July, August, so temperature matters. But for snow, PI is low, so that is not robust. But the surface temperature is robust because, high PI values, and also rain effects. So this is one phase. So this is a bit in one phase. For example, the niche in the tropical forest in the Central Africa is predicted less. So that the more minute the detail, the observation can be possible, but I skip the for the reason of that time today. So, so this is the difference in the niche probability of UP period. So the southern Himalaya, the one phase that is more that is in from 1 minus cold. It means for cold phase, this corridor is explored. And also, this is the comparison of difference of UP and MP niche probability during the cold phase. So in this case, it's for the northern part. That is obviously high latitude zone is the UP population is good for higher latitude zones, Scandinavia and also Tibet and also Eastern Asia. But this is the same. In the one phase, this is also the UP population can go to the northern higher latitude zone. So I want to show the interactive maps, but time is limited, so just I skip this slide. So this is a summary of today's lecture. So I'm talking about the ecological niche modeling for modern humans niche construction. The ecological niche was compared between different stone groups extracted from the PaleoAsia DB. under the assumption that the technological difference reflects the differences in niche construction strategies of human populations using them. And for the analysis, I have employed Maxent, an ecological niche model algorithm based on the theory of maximum entropy, to explore the ecological niches of both middle and upper Paleolithic tool groups, using known archaeological sites and environmental factors derived from palaeoclimate and palaeoterrain models. And as a result, high probability areas were generally observed in the middle and latitude zones of Northern Hemisphere, particularly in Europe, the Mediterranean, and East Asia for both MP and UP groups, with some regional anomalies in the niche probability. For example, in southern Himalaya was highly high despite the absence of known archaeological record. That is interesting and important. Such a gap between archaeological sites and model simulations may advance future research towards a better understanding of human ecology and behavior. It means, for example, please, we can survey southern Himalayan regions to find middle Paleolithic could be. So that model says so. But the archaeological evidence we need to explore in the future. So that's all for today. So thank you for listening.
My thanks to Professor Kondo. That was a fascinating lecture. If there's any questions online, there's only a handful of people online. If you'd like to type them in the chat, we'll try and get around to them. But otherwise, if anyone has any questions, we don't have a microphone to pass out, so please speak up. If you don't speak up, I shall repeat the question for the benefit of everyone and to your embarrassment. So, Jess?
You knew this was coming.
That's for you, not me.
Is it possible to do this modeling at a higher spatial resolution? For example, if we wanted to model with 1 pixel being equivalent to 1 kilometer,
1 kilometer.
is it possible to use this algorithm to achieve that?
Yeah, it depends on the the grid, the number of pixels. This simple, for example, 30-kilometer model that can cover the globe in some, for example, 10,000 by 6,000 or something pixels. That can be calculated by very generic workstations, and it depends on the window, the scale, geographical scale. If models are originally developed to predict the probability in the global scale or continental scale. However, if you go, for example, 1 kilometer, that could be a regional scale. That is possible, but we need may need a different data set, background data set. So it depends on the scale issues.
Thank you.
Yes, please.
So, there's been work recently in Western Europe to look at the dates of neolithization using Bayesian modeling, revisiting all the published radiocarbon data. Do you think something is possible for this database, or is the date range too extensive?
Yeah, you can try because that model is simply using presence and absence data. But yeah, I know, for example, the recent work by Enrico Kramer, Cambridge team, that means heuristic weight, so that the probability of time. So that may be advanced. This model using Bayesian is a very good thing. May very fruitful, I think.
Couple of observations from this film. The niche modeling and the area optimum niches identified. I mean, I suppose there's two things. One, it's very interesting that you've got span from China, essentially East Asia to Europe. And one presumes, though, to an extent, the areas to the south, particularly in Sundaland, are becoming less than optimum, largely simply because of the absence of evidence. The other thing, which is going right somewhat wacky out of the time frame, is the work which was publicised this week about early human division in China, suggesting that you might have an out of Asia movement of people rather than an out of Africa. Now, it is only just been released, that's quite problematic, but one presumes, although obviously your model does not apply to this really directly, the potential of that optimum niche across Asia, India, Europe might be significant if the work was done for an earlier time.
Thank you very much for your comments. Yes, actually, this model is biased by the presence data, occurrence data. So yeah, the Sundaland, there are very limited data for example, even for Upper Paleolithic populations. So I avoid to determine, for example, this is represent the Homo sapiens niche first. This is simply reflect the archaeological data of distinct. So that is now it is turned out. So because of Middle Paleolithic, the Lubaroas is not only Neanderthals but also Homo sapiens use this, and also some the lithics in Southeast Asia and East Asia is really not so much typical the UP. Seems very difficult. Even chopper is in Upper Paleolithic. So that's kind of biased data should be carefully examined. Even we don't count the genetic data. So that is our the limitation, but it needs the future study, of course.
That's where we need to work as well. The coastlines and the southern landscapes do come before, particularly since the dating for habitation in Australia is moving quite rapidly. They moved up and down. Which is a bit.
So that's interesting because simply applying the climate data, for example, this the southern coast of Australia continent predict a bit high. That's simply a similar condition or somewhere in other places that in which the presence of archaeological sites is observed. Yeah, that's interesting.
Any further questions for Professor Kondo? I have one.
Please.
It was fascinating. I started out doing Paleolithic archaeology, so it's very interesting for me. You mentioned, the model is to some extent biased by the occurrence data, and it strikes me that in places where archaeologists have identified multiple technocomplexes, you may have an increased number of, I guess, niche adaptations if you're measured on lithic industry. So in places where you have potentially higher populations or higher rates of cultural exchange, and I'm thinking the first Upper Paleolithic, all the variants, you might see different, Lucian, Shadowperonian, all these things. Does that skew the data or?
Actually, I tried the prototype of this research I conducted with, for example, initial Upper Paleolithic. That's previous called Iran, and also the William Banks team conducted the same for Proto-Aurignacian and Magdalenian. So as you know well, the techno-complex evolved very rapidly in Upper Paleolithic in comparison to Middle Paleolithic.
Sure.
So if taking this techno-complex, the time span, short time span, we can predict individual techno-complex niche, but that is maybe the regionally limited due to the definition of techno-complex. That is divided regionally. So in this study, just using this as a large scale, the grouping, just simply UP, makes it possible to draw this picture. If that is a limitation of us regional archaeologists. If doing the detailed research, the classification or typology of techno-complex, that may be getting the regional, the complex, that is okay. But if thinking about wider context, we need some kind of integrated study. So that's two approaches. Yeah, so good combination is important, I think. Yeah, thank you very much. That's a very important point. Yeah.
On the subject of thanking you, oh wait, we have a few more questions. Sorry.
It's less of a question and more a comparison, again with a different scale. My colleague Philip Verheeg at the University of Leiden has looked at cultural memory on much shorter timescales, looking at place and landscape and previous cultivation and previous enculturation of a landscape and then a population returning. And he's looked at that in relation to the Roman period and then later Iron Age, post-Roman period sites and kind of this historical memory. And that seems to me to be a much smaller timescale version of this. I can't remember the phrase now. The contribution of kind of material culture and cultural tradition to exploitation of landscapes. It was just fascinating that the big scale thing reminded me of the very small scale.
Local scale.
Yeah, people coming back to places that have been previously cleared for agriculture, even if the fields aren't still present. And this current reuse of sites that go in and out of use, and that there may be some cultural memory involved.
So is it a quantitative method?
Yes, yeah.
Yeah, that's interesting. Yeah.
Yeah, he's finding some references.
So I don't think the same method is simply applied to the local scale approach, but for example, machine learning process, and that is now called deep learning, and then maybe next generation AI coming. So that can be applied without some the specific spatial scale. So that local scale you can apply, and the regional scale and the global scale. So we must think about how we can choose appropriate and also statistically robust quantitative method. Yeah. Thank you very much. Yes.
The model is biased because towards the places where there's already knowledge of humans. You try running the model without any of the information about people and just saying what would just the climate and rainfall and everything else suggest is a good place to live.
Oh, I see. Thinking, so this model has, for ecological niche model, we need certainly input. So if we do, if we do this truly random, using random data, just like jackknife, we can, so do that. Yeah, we can do that. Yeah.
Location of sites and population. If you just had all the paleo-environmental variables, say, just run it on that and say, where's a good place to live?
That's a good idea. Oh, I see.
Yeah.
Thank you very much. I never think about that, but yeah, that could be a debate in ecology. Yeah, that is also case for the niche conception of the other species. Yeah, very good. But still, the random test is performed background, at least. Yeah. Thank you very much. Yes, please. Next, yeah.
Just about the base data sets. So is there any variance in the reliability based on location? Is stuff in China more reliable in terms of snowfall than so is that kind of
Yes. So yeah, to be honest, I selected this parameter, the variables obituary. There are set hundreds of parameters. So yeah, the next version we must count all of the parameters that was simulated by the previous modelers. Yeah. Am I answer your question correctly? Yeah. Yes, please.
Would we be able to use like this model that looks at submerged landscape so forth?
Submerged landscape. Very good questions. Yeah, this model, yeah, that is also, I should confess that, yeah, this model doesn't count the water area. Only, yeah, that means, yeah, we can, the people can walk, even the bottom of the sea bottom. But, yeah, this model, it's possible. For example, we can count, for example, the direction of water flow and also water temperature and other parameters in the water conditions. And yeah, this simply doing machine learning to explore the occurrence possibility. So we can apply, yeah, basically. Please, I hope you can try.
I think we might call it there if that's okay, but I believe we're going to depart to somewhere to get a drink and possibly some food. So everyone is very welcome. This is quite normal if you haven't been to these before. I'd just like to say on behalf of everyone here, Professor Kondo, thank you ever so much. We have a very small token of our gratitude. You can put it in the bubble wrap. Thank you very much.
Thank you very much. Thank you very much.